Hello everybody! This video is going to teach you about systems of equations in word problem format. This will probably be some of the nastiest word problems you've ever seen so far. They're really not that bad though. Let me look at the first one that I have here. This is a really simple example. 2 times a number added to another number is 25. So before we read any more, what I want you to do is look at that first sentence. 2 times a number added to another number is 25. Can you write that? You should be able to. First of all, 2 times a number. Okay, well we can say that's 2x. And then added to, we know, okay, that's addition, another number. Well, we can't use x because it didn't say added to itself. It's to some other number. We don't know what that other number is. So we'll say that's y. And then is 25 means equals 25. So we took that sentence and we turned it into an equation. Now, if you look at the next sentence then, 3 times the first number, meaning the first one that we had here, or x in other words, 3 times the first number minus the other number, which was y, is 20. And you have to find the numbers. Okay, well that's simple enough. We have a system of equations now we can solve. And the method that you choose is really kind of up to you at this point. I'm going to choose to do elimination because when I look at the y's here, they have the same coefficient there. They're 1. Now, top one is positive 1, bottom one is negative, so I'm going to add these together. 3x plus 2x gives me 5x. The y's disappear, and 25 plus 20 gives me 45. Divide by 5, and x is 9. Great, I just found one of them. And then what I'm going to do is take 9 then and substitute it into the original, or one of the original equations. So I'll do 2 times 9 plus y equals 25, and I'm going to solve for y. So I have 18 plus y equals 25. Subtract 18 from both sides, and y is equal to 7. I'm sorry if you hear all that noise in the background, the music. It's band practice time. So anyway, before when we solved the system of equations, we listed the solution as an ordered pair. When you're in a word problem, you don't want to do that. You want to make sure you answer the question. Here it said, what are the numbers? So you would just write down the numbers are 7 and 9. Oh, I shouldn't even put the parentheses around because that makes it look like it's an ordered pair again. Just put down 7 and 9. Those are the numbers. Okay? Now, let's try one though that's not as clear as this one. Here. At a baseball game, Grant bought 5 hot dogs and 3 bags of chips for $14.82. He was really hungry. He must have used his birthday money to get that. Annika bought 7 hot dogs and 6 bags of chips for $22.89. You need to find the cost of each hot dog and the bag of chips. Now, you can write let statements if you want to, if that's helpful to you, but what I suggest you do with these type of problems, and really any word problem, go to the very last sentence. It'll almost always tell you what you're solving for. So here, we need to find the cost of each hot dog and a bag of chips. So I am going to even erase part of this and say, all right, what we're really looking for is the cost of the hot dog, cost of the bag of chips. And what I'm going to do is say, all right, well, the cost of the hot dogs will be x. The cost of the bag of chips will be y. Then, when I'm setting up my equation, all right, Grant bought 5 hot dogs. So he bought 5 times the cost of a hot dog, will be how much he spent for the hot dogs. And he bought 3 bags of chips. So plus the 3 bags times whatever the cost is per bag, and he spent a total of $14.82. Okay, then Annika bought 7 hot dogs. Annika, that's a lot of hot dogs. So 7 times x here, and then she also bought 6 bags of chips. Must be feeding a lot of friends. And she spent $22.89. Okay, that's the way you need to look at this. All right, so I was solving for the cost of a hot dog and the cost of a bag of chips. So you have to take how many they bought times the cost, which we don't know. There's our variable. Add those things together, and that's what our total is. Now we have two equations, and we have a system here, and we could solve for x and for y. So when you look at these, I'm going to use elimination again, because everyone seems to like elimination. And what I'm going to do is take the first equation and multiply by 2 so that I get rid of my y's. So I'm going to take this entire equation and multiply by 2. Remember that when I multiply, I have to distribute to everything on the inside. So this will become 10x, and then 2 times that 3y, I get plus 6y, is equal to 2 times 1482 is 2964. I did not do that mentally. I had that written down. Okay. This one then stays exactly the same. I didn't multiply it by anything, so I just have 7x plus 6y is equal to 2289. Now, look at the signs here. There's positive 6 and positive 6. How would I make that 0? I have to subtract my equations. So 10x minus 7x, I get 3x. 6 minus 6 is 0, that's gone, is equal to 2964 minus 2289, which is 6, I think that's 75. I think that's 75 or 615. That part I tried to do mentally. Mistake. No, that's 675. Okay, I'm right. Okay. And then I divide both sides by 3, and x is 225. Now remember, we were talking about cost, so technically that should have a dollar sign in front of it, okay? Now, what does that 225 represent? Well, look back up at our problem, and it's the cost of the hot dogs. Great. Now let's find out how much the chips are. So we take one of the equations. I'm going to take this 5 times my 225 plus 3y is equal to the 1482. 5 times 225 is 1125 plus 3y equals 1482. Subtract 1125 from both sides, and 3y is equal to 3, I think that is 57. And then divide by 3, and y would be equal to $1.19. And that is the price of the chips. So what you would say is, and you should answer this in a sentence, but I'm not going to do that because I want to make the video really long. I'm going to say the cost of a hot dog is $2.25, and the cost of the chips is $1.19. Okay? Now, let's go on to a beast, probably one of the worst ones you'll see. You ready for it? Dun, dun, dun. Here we go. Look at that. Look at all those words. This is a typical math word problem. Let's throw in a bunch of words and see if we can make it really confusing. I want to read through it and see if we can figure this one out. Disney held a breakfast for parents and their children to eat with Mickey and Minnie Mouse. Yay! And the rest of the gang, too. Adult tickets cost $17.95, and children's tickets cost $12.95. Disney made $7,355 from ticket sales from a total of 500 people that attended. How many adults and how many children were at the breakfast? Now, if you're like me, when I was a student, I would read through a problem like that, and by the time I got to the end, I didn't even remember what was said in the beginning. So, we need a strategy. Again, go to the last sentence of the problem. How many adults, I'm going to highlight it, how many adults, how many children were at the breakfast? That's what you're solving for. So, adults will be my X, the children will be my Y. Okay? Now, putting this one into a problem isn't going to be quite as straightforward, at least not as the last one. When you look at this, you say, all right, well, it's $17.95. First of all, if there's money in the problem, you're probably going to need it. So I got $17.95, and I got $12.95. I got 7,355, and I got 500. I had to figure out how to use those numbers. So $17.95 is how much a ticket costs for one adult. So in other words, if I took $17.95 times the number of adults that were there, that would be how much money was made from adults. Plus the $12.95 here is the cost for a children's ticket times the number of children that came would be the cost for the children. Those two things added together should equal that $7,355. Now I know what some of you are thinking. Mr. Jones, that doesn't make any sense. I only got 500 left. What am I supposed to do? All right, let's think about that. What we're trying to do is figure out how many adults and how many children actually showed up. So this equation that we wrote is going to help us to solve. That's one thing that we need. But then when you think about it, all right, well, how many people were actually there? There were 500 people that were there. And how many of them were adults? Well, we don't know. X of them were adults. How many of them were children? Well, we don't know. But we know that all of them together were 500. Okay? Now we have our two equations. So if you have to rewind this video and listen to that again, do that, because I want to make sure you really understood where I came up with that, because it wasn't as clear as the last one where it said so many hot dogs, so many chips. Okay? Now, let's see if we can solve this thing. What I'm going to do, I am going to take, how are we going to do this one? How about elimination? Seems to make sense, right? What if we multiplied the equation by this one down at the bottom by 1795, and then we'll get rid of the x's. How does that sound? Yes? No? Maybe? I think that sounds good. All right, so what I'm going to do is, actually, I'm not going to do that. What I'm going to do is substitution, because some of you guys don't like substitution, and you got to get used to it. So let's do substitution. I'm going to do that. If I took this equation and I subtracted the y from both sides, what I would have is x is equal to negative y plus 500, because I subtracted it from both sides. Now what I'm going to do is I'm going to take this and I'm going to substitute. Hold on, let me erase what I just did. I'm going to take this right here and substitute it for x in the first equation. And again, I'm doing this because I know some of you really hate the substitution method. Maybe you just need to see it a little bit more. So my first equation says 1795 times x, which I say is negative y plus 500, plus 1295y should be equal to 7,355. And then I'll distribute the 1795 to both things on the inside here. And I have a negative 1795y plus 8,975 plus 1295y equals 7355. Combine my like terms with negative 1755 and 1295. One's negative, one's positive. I end up with a negative 5y is equal to, and I'm going to take this, I'm going to do two steps at once. I'm going to subtract this 8,975 from both sides at the same time. So I end up with a negative 1620 over here. Divide by negative 5 on both sides, and y is 324. Now, what does that 324 represent? It represents the number of children, because we go back to our original problem. So I'm kind of out of room here. What I'm going to do is come off to the side, off to this left side now, and I'm going to put y into this first equation. So I have x plus 324 be equal to 500, and then x would be equal to 176. So I should answer this in a sentence, but I'm really low on room here. Let's see if I can make this work. So I'm just going to say adults is equal to 176. Children, sorry, this is getting really scrunched here, 324. And that is a total of 500 people, okay? I like that. I like that. You should get used to doing both methods. For this one, it seemed to make sense to use substitution. Because you have the x and y, you can very easily change that to either x or y equals something and then substitute it into the other equation. I was going to avoid it because I know you don't like it, but that you should get used to it. Okay? Now, the last one I want you to try on your own. By the way, all of these problems better be written down in your notes. I wrote them, I typed them, you're writing them. Now, go to this last problem. This one I want you to do completely on your own. Billy, don't be a hero. Okay, Billy has 60 coins consisting of quarters and dimes. The combined value of the coins is $9.45. Find how many quarters and dimes Billy has. I want you to pause the video, write this down, solve it on your own. Okay? Do it. Pause the video now. This is the way you're going to know whether or not you're actually getting this. Did you pause the video? I hope you did. Okay, so let's see what he has here. He has quarters and he has dimes. We want to know, find out how many quarters, so I'll make that X, and how many dimes. I'll make that Y, okay? Now, the nice thing about this, we're talking money, so you know that a quarter is 25 cents, and you know that a dime is 10 cents. At least I hope you do. So when we're setting this up, we can easily come up with our first equation by saying 25 cents times the number of quarters would be how much the quarters are worth, plus 10 cents times the number of dimes would equal the value of the dimes. Both of those combined would be the value of his money. Great, there's your first one, okay? Now, your second equation, you have 60 coins total, and the quarters plus his dimes would equal the 60 coins total. Now we could solve it, okay? So I'm going to do substitution again. It makes sense because you have x and y here. It just makes complete sense. I'm going to get rid of that y, and I'm going to have x is equal to a negative y plus 60. If I put this into the other equation, then I have 0.25 times x, which I'm saying is negative y plus 60, and plus 0.10y, or that's 10 cents, 10.10 times y is equal to 9.45. Going to distribute here, like that. 0.25 times that negative y, I get a negative 0.25y, and that becomes plus 15 plus 0.10y. You got to be careful if you don't have that leading zero. It's easy to kind of miss your decimal. 9.45. Now combine my like terms, the negative 0.25 and the 0.10, and I get a negative 0.15y, and I'm going to get rid of the 15 at the same time by subtracting it from both sides, and that'll be equal to a negative 5.55. I'm going to divide both sides by that negative 0.15, and y is equal to 37. 37, again, is the number of dimes. All right, then I'll go to this equation right here, and I'm going to say x plus 37 is equal to 60. Subtract 37 from both sides, and x is 23, and that's how many quarters I have. So Billy has, where am I? 23 quarters and 37 dimes. And we know it's worth $9.45. Maybe he's going to take that and cash it in so that he could buy lunch when he goes out to the jazz band concert field trip. Anyway, that is word problems, my friends. See you later. Have a good night. Bye-bye now.